Hi students, this chapter we are going to look at the qualitative analysis. So this is one big chunk of your O-level practical, as well as this whole chapter can be tested in the theory. So it is very important for us because the practical takes up about 20% of your overall paper. Okay, so qualitative analysis is to help us to identify the unknown solution. What are the ions in the unknown solution? So we have the cations as well as the anions in the next page. Okay, so to identify the positive ions, we add the NaOH and your NH3 aqueous. So both are alkali. We have the strong alkali or the weak alkali. So since both are alkali, the ions that we are really interested in when we add the alkalis in is your hydroxide ions. So NaOH, I can see the hydroxide ions are here, but in your aqueous ammonia, right? How do I get the hydroxide ions? It's because ammonia itself is a gas, NH3, non-metal bond to non-metal. This is a simple covalent structure, low melting point, low boiling point, so it's a gas. How do I change it to aqueous? I dissolve this gas in water. So to dissolve it, I get NH3 aqueous, which is the same as my NH4OH, the ammonium hydroxide, right? Water is H, OH. Whenever you see ammonia, think of ammonium. One of the H go over to get my NH4. NH4 plus will partner the OH minus that's left behind to get my ammonium hydroxide. And that's where I have my OH minus ions. Okay, so this is very important because when I add the alkali drop by drop and in excess, right, my cation is reacting with the anion. Okay, so when I add drop by drop, I will always get the hydroxides because the positive ion partner the negative ion. Okay, so step one when we do it is to classify the colors of the precipitate that I'm going to see. So I group them according to white and color. Okay, so white, I will have my calcium and the Z. So zinc, aluminium, and lead. If you cannot remember this Z, this is amphoteric. Right, so the Z ions are amphoteric, meaning to say they react with both acid and base or your alkali. Okay, so what's going to happen when I add the strong alkali drop by drop? My calcium will give me CaOH2. Recall your solubility. All metal hydroxides are bases and they are insoluble except the group 1. So metal hydroxides are bases and insoluble except group 1. So calcium hydroxide is insoluble, okay, when I add the alkali. Okay, it's white in color, so the same is the same for your Z hydroxides or the Z ions, right? You will get your zinc hydroxide, which is insoluble, aluminium hydroxide, which is insoluble, lead hydroxide, which is insoluble. And all you will see white precipitate, which looks like this. Okay, this is cloudy, it's white precipitate, white precipitate. Okay, and then the Z being amphoteric means they can react with both acid and alkali. So when I add excess NaOH, right, this is going to act like an acid because it's amphoteric. It's no longer just base. Okay, it's acidic. So it will be soluble. It dissolves. It is acting as an acid. It acts with more alkali and it is dissolved and it forms a salt. That's why it is soluble. Okay, so my amphoteric ones are all soluble in excess alkali. Okay, so since my calcium is the only one that's insoluble in excess NaOH, I can identify Ca is the only one that is insoluble in excess NaOH, right? So my zinc, aluminium, and lead, they are all soluble because they are amphoteric. I have to do additional tests. So in an additional test, what do? Right? I add the weak alkali. So I add my aqueous ammonia. After I add my aqueous ammonia, I still get the hydroxides because aqueous ammonia is an alkali. The cation will partner the OH minus to give me the hydroxide, which is my white precipitate. Okay, zinc is the only Z that is soluble in both the alkali. So zinc is the only one that's soluble in both the alkali. All right, and then I add in excess, I will get insoluble for both my aluminium and lead. Okay, so aluminium and lead insoluble in the weak alkali, right? I cannot conclude which is aluminium, which is lead. So the next thing I have to do is to add another reagent to the sample. So I'm going to add potassium iodide, Ki. Okay, so remember this one goes with your solubility table, right? My silver chloride and lead chloride is insoluble. They are all solid. So when I add iodide, which has the same solubility as the chloride, right? So my Ali3, when you swap partner, this is soluble. But my PbI2 is going to be insoluble. And that is when I will see a yellow precipitate of lead iodide. Okay, so after I add Ki, I'm going to swap partner. My potassium is going to swap with Pb, and my Pb is going to partner the iodide to get PbI2. And it is insoluble because of your solubility table. Okay, so I talked about the white precipitates. Then I'm going to talk about your colored ions, your colored cations. This is your transition metal ions. Most common, we have your copper, iron 2, and iron 3. So these are the color: blue, green, and then reddish brown. Okay, so same thing, I add the alkali drop by drop. Okay, so copper is insoluble in excess sodium hydroxide, gives a blue precipitate. Okay, iron 2 insoluble, give a green precipitate, and then if I leave the iron 2 ions to stand, the green precipitate will get oxidized with oxygen and water in the environment to give me reddish brown, which is my rust. Okay, and then iron 3 itself is red brown precipitate. This is the rust itself, and it is insoluble in excess. Okay, copper will dissolve in weak aqueous ammonia to give a dark blue solution. So this is my dark blue color. Okay, and then same thing in aqueous ammonia, it is still insoluble. It is still insoluble because they are not amphoteric, they will not dissolve. Okay, so most important thing over here, right? Please know, since I'm trying to identify my cations, I'm trying to identify the positive ions. The positive ions will partner the OH minus, and these will give me the precipitates. Okay, your precipitates that you see are all the hydroxide ions. Okay, calcium and the Z are colorless, right? They form white precipitate. Okay, calcium is the only white precipitate that is insoluble in excess NaOH, and there's no precipitate in NH3. Zinc is the only one that's soluble in both the alkalis. Okay, and then NH3 will be given out in the presence of nitrate ions plus aluminium and NH4 plus NaOH. Okay, so this sentence means, right, whenever I see a pungent gas form, which is my ammonia gas, it's either the nitrate ions or the ammonium ions. Okay, When you see nitrate ions, you must add aluminium also. So these N ions we will discuss in the next page.